Hello, hello, it's Mr. Montana here. All right, nice to see you. It's going to go kind of fast, so let's pay attention. We're going to do fractions. What do they mean? All right. So, one more important thing is the denominator, D for down. So, denominator is the part of the fraction that goes to the bottom. For example, 4, right? That means if we have a pizza, it's split into 4 parts. The number on top, the numerator, uh, let's say it's 3. So the numerator is 3. It tells us how many slices of pizza. For example, 1, 2, 3. We have 3/4. Remember, that's important. Denominator, numerator. Not too much wordage, but you have to know it, right? And it's just like a pizza. How many parts are you going to cut it into? All right, so let's say we're on a number line. So let me put the denominator, D for down, numerator, number on top. All right, there's no little D for down, denominator, right? Now, on a number line, we start at 0, and let's say I'm going to cut it into, and then we have 1, and we have 2 over here. So, I cut it into parts, okay? Now, I pretend they're equal, all right? So, I would start here, I would go 1, 2, 3, 4. Right on the 1, it's 4/4. Because if we have a pizza and all the slices are taken, that means it's a whole. It's a complete pizza. It's whole. So that's why it's called 4/4. It always ends there, right? And this is 1/4, 2/4, right on the line, 3/4, 4/4, 5/4, 6/4, 7/4, and this is 8/4. All right? Notice how it's called an improper fraction because the numerator, number on top, is bigger than the denominator. Okay? That's important. And let me show you why. All right? Now, when you have fractions, remember, a fraction, the line here means division. And you could also put it this way. For example, the 3/4 we're doing like this, right? Let's call it 8/4, right? That was the number 2, right? 8/4, division sign, right? So if we have 8/4, that means that equals 8 divided by 4, which we know is 2, the answer. 2 wholes, two whole pizzas. Because if we have 2 pizzas and they're cut into 4 parts, and we have 1, 2, 3, 4, 5, 6, 7, 8. We have 2 whole pizzas. It's like magic here, huh? But this is important. When I do it online, of course it's going to look like that a lot because that's the same thing as this, okay? The slash means division. You got to remember that. Now that's quickly how we do this. And now we're going to go to mixed numerals, okay? Because this, what I mean by mixed numeral, it's going to have a whole number and it's going to have a fraction. For example, this is, that's a whole number, right? But let's say we add one more slice of pizza. And this time we only get 3 slices. Right? Because the Uber Eats guy or the Grubhub guy ate one of the slices. They do that sometimes. So what we have is 2 pizzas and one is 3/4. This one's 4/4. This one's 4/4, right? So if you add the slices up, we got 4 and 4 is 8, 9, 10, 11. We have 11/4. But if we look at it, what 11/4 is, let me put it over here, that really equals 2 whole pizzas and 3/4. Thus, the mixed numeral. Okay? That's how it's going to look. And look at this. What we did is we did 2 4 times. So a shortcut to figuring out how to get back to here, 11/4, is 4 times 2 is 8, plus the 3 slices, which is 11/4. Okay? All right. Let me see what I'm doing here. Next. So an example of what we're doing. Is so on the book, and if you want to follow on the book, we do start at page 144, division, and we go on from there. So let me do it quick. So let's say we have this time let's go with 6s, right? Let's say we have let's call this 13/6, right? So the way this would look like if we decompose it, right? I would say 6 plus 6 is 12, right? Plus 1. Why did I do that? Because I know 6, right? The denominator is 6. It always stays the same. We don't add the denominator. We only add the numerator. And this is 6, right? So when we add them, it's 6 plus 6 is 12. Plus 1 is 13/6. And we can easily see that this is, and let me see if I could divide it into 6, I mean. This is a whole pizza. Oh, I'm doing terrible here. And this is a whole pizza. Pretend there's 6 slices. And this one, let me draw a little better, this one. There is only 1 slice. This one's the whole thing. This one's the whole thing, right? So you can easily see, this is why I did it this way, because you can easily see that 6 and 6 is 12, plus 1 is 13, but I could also see I got 2 whole pizzas and 1 6. That's what 13/6 is. And you could also find that on the number line. Now, a lot of students on Dreambox have been doing equivalent fractions. And we're doing equivalent fractions, but that is really important. So we need to find fractions that are the same. For example, my father used to always say, give me a 3/4 wrench. And then I say, okay. And he'd go, give me the next big one. So I would go, where's the 4/4? There was no 4/4, right? You had to go into 16ths. And so that's exactly what we're doing. For example, let's say we have 3/4, right? We want to know what's equivalent. Okay, remember this. Remember how 6 was a whole? So 4/4 is a whole. Actually, 99/99 is a whole. That means we cut the pizza into 99 parts. It could be done. I never tried it. I did do 100 candles one time on a kindergarten birthday cake. That was not a good idea. Anyway, don't distract me. Let's go back to this. So we're trying to find an equivalent fraction. So we start off slow. Let's multiply it by 1. Isn't 2 2s 1? Isn't it kind of crazy? Equivalent means equal. So we want to find something equal. 3, whatever you do at the bottom, you do the top. Whatever you do at the bottom, but whatever you do at the top, you do the bottom. Whatever you do at the bottom, you do the top. You got to be equal. Now, this is 1. 3 times 2 is 6. 4 times 2 is 8. Now, 3/4 and 6/8 are the same thing. They're equal. That's why it's called equivalent fractions. Now, I could prove it because I could go like this. I could go like this and cut this in fourths, right? And I could do 6, 1, 2, 3/4, right? And then 6, I'll try to draw a same one here, right? And I'll try to go even. And this is by 8s, right? So I'm going to cut it into more pieces because now the denominator tells us it's cut into 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. Usually I don't go this fast, but I'm going this fast for the parents. Usually this is like 4 days of work crammed into hopefully 30 minutes. Okay, so now we got 6 8s. 1, 2, 3, 4, 5, 6. Notice how they're the same. They're shaded in the same. That's why it's called equivalent fractions. All we did was double it. Now, we can't be drawing pictures all the time. Well, I guess I could. I would like that. But let's say we have a bigger number. Or we could do another number. But what's going to happen in 5th grade and 4th grade, And in Dreambox, there's going to be something like this. Let me see. I'll go with 6. Let me give it 4, 6, right? And they're gonna have an empty box here, and they're gonna have let me see. They're gonna have a 12 here, and they want you to. And these are equal. They want you to find the equivalent fraction. So what do? This is why it's important for the students to know the multiplication tables, because right away I know that 4 times 3 equals 12, right? Hey, what's calling me? And now, whatever I do to the numerator, I do to the denominator. So I put a 3 here also. And notice this is 3 3s. This is 1. That's why we're getting equivalent. Isn't that crazy? Actually, the only number now you can put is 3, only because it's got to equal 12. Now, 6 times 3 is 18. 12 18s is the same as 4 6 because we multiplied it by 1. Crazy, huh? That's how you find equivalent fractions. That's going to be on the test. One more? I don't know, I'll do one more. What the French fries? Okay, so let's say we have let's do an eighths, right? Actually, let's do a fifths because everyone loves the 5 time tables. So I got fifths, and I got let's go 3 fifths, right? And over here I have 30, and we got to find out this one, right? So right away they're got to be equivalent, and I see something right away. I see that 5 times 6 equals 30. Now, remember what I always say. Whatever you do to the bottom, you do the top. So, I go to the top. I put another 6. That's a 1, right? So I multiply this numerator and this numerator. 3 times 6 is 18. This is equal to this because I multiplied it by 1. Those are equivalent fractions. All right, back to mixed numerals. Sometimes they don't always add up that nice, right? Let's say we have 14 eighths. Oh, I did this one already. So what do? All right, what you do is I start with 8 eighths, because that's a whole number. 8, 9, 10, 11, 12, 13, 14. And you get 6, because 8 plus 6 is 14, and that's 6 eighths. So now I could see easily that this will equal 1 whole, right? 1 whole, and 6 eighths. My mixed numeral. All right? You're going to find this on Dreambox also, so they can practice. A lot of times they'll have a little monkey and bananas. I don't know why, but I guess monkeys like to eat bananas. And they'll do the little boxes, and and then they'll just continue like this. They make it a little easier. They'll do like 3/4, and they'll say times, and they'll have a top number 9, and then you have to multiply the 4 times 3 to get 12, and then students will have to get let's say another times 3, it'll be 27, and so you know that 9 times 3 equals 27. So whatever you do to the top, you do the bottom. Have I mentioned that already? I think so. I do that to the students also. I repeat a lot. I repeat a lot. A lot. Okay. So times 3, and that's 33, 34, 35, 36. See how I did that? All right. And those are all equivalent fractions. Okay. Thank you, and check out Dreambox. And hey, there's only 15 minutes. Wow. I really crammed that. If you have any questions, please call me.